So, we've got the burner here, and over here, take a look at it. You see what matches up there is right into here. This little piece right here is what's going to pull itself in and raise it up. That's a little rock. And you can see what's happening right here. It's latching on to this piece. This is your release. So, slides it here like so. What you're trying to do is you're trying to center this and this. See these little points here? Okay. So when you put it in, be sure if you've got Stu's doing, there's some plastic little put this in there. The pin's metal. It's kind of just make sure you center it in there, and then once you get it, you pull it. Then it lock right in. Okay? So, I didn't know where you really want to put this. This is way too long.
It's always been.
Right there? Okay. So, what I'm going to do is, I'm going to cut that off. And the reason being is there's, when you look in there, there's a Teflon coating.
Oh yeah, look at that.
And that's for organics. And once you keep that,
Yeah.
the tubing will come back out, but the Teflon blocks it off. Slide that up there. Just going to slide that on there because you might be taking it and running off after it's really tight. Just like the other. Okay. So I'm going, so I don't end up with a key. Key cap is right there. I'm going to do it like this. All right. See these openings? Here. Goes up, get it out. So this has to come out of the way from the furnace. So, talking about turning on, we're going to use your lamps. So I've got, there's two lamps here. I've got one, a new one, and I got one of the old. So you can see what's going on there. Yeah. So we're going to go here. And then we're going to plug it in. Now, this is a universal adapter, so we have to tell it. We're telling them it is. So to turn the instruments on, here's the power switch. You can see it right here for the furnace. You don't turn this off and on. The furnace will turn it off. There is physically a switch back here. Leave it on. That way the furnace, when it calls for water, it can get it. So it doesn't make any difference which one you turn on first. Turn on the furnace and the AA, or AA in the furnace. You'll hear the furnace do its little.
You're just using the flame. Do you have to turn on the furnace?
No, not at all. Now it will come up in the software.
Yes, it's a
It will say it didn't initialize because I've got it configured for it. Yeah, but this is where it's rated on. Okay. I want you to be familiar with sounds. So this thing when it first comes on does nothing. It's slow to come up, and then it will drive its motors to their home positions. It takes a little while. This is referred to as the e-box, electronic box.
Is there an order?
No, it
So the
doesn't
computer
matter.
can be shut off or on,
Yeah.
the instrument can shut off or on, the software initializes the
Right.
instrument.
Yeah.
There's no problems.
So, well, there you go. That's how long it takes. And then what it's doing now is this was to be a 4-element instrument and do them all at the same time, simultaneously. So what you have in here for the micrometer is a grading aneurysm, like scanning ICP. A minute and a half later, it's a long time. So this is very complicated optical designed for a low-end AA, but they had issues getting it to come into the price range that they wanted, so they back engineered it to a little bit. So it makes it slower to set up, but it's a very good instrument.
But it can do multi-elements at once.
It can-
I was gonna say,
Yeah.
with flame.
No, no. They were going to,
ICPs can shoot
Yeah.
multiple.
but they were really going to have it's 4 lamps, and it's got the monochromator to scan across them.
Oh,
No, but they had issues with making it work the way they wanted it to, so they just made it like a normal AA.
okay. But they left the high-end optics.
Yes, they did. Yeah,
That's awesome.
yeah. Okay, so getting into the software, I put a little icon up here. We talk to it serially. And I click on this and change adapter settings. It will say one incoming connection. That means that the instrument has initialized and it's ready to talk to it. That you don't have to have. It's just, if you ever call me up and say you can't talk to it, then this is part of the networking.
Yeah.
I do it there.
It's still IEEE. You guys are still.
No, it's serial.
Oh, that's right, you're right. That's
It's
right. You told
serial
me
to
that.
the
It's serial to
instrument
the instrument,
and IEEE to the
IEEE
furnace. Why? Because this furnace was never to be put on. They didn't envision it being on. But this furnace went on a lot of different things. So realistically, the processor that they used for the furnace carried over from the older one. So that's why it's IEEE. Yeah. So they call it Syngistics now. It used to be AA WinLab.
Yeah, win
So,
Analyst.
yeah. So on that, here I have an offline version for you, which if you want to go in and modify methods or reprocess data, anything but instrument control, you can do over here on the offline. Data manager. Same. Did you ever work? Okay. Well, the only thing we have is, well, luckily, versus the old one, the old one that went to that would have been Borland database.
Yeah.
And then this is Microsoft Access. So the only two things that we have in our databases are results and methods. Everything else, like sample information files and all, are text files. So you double click on it. And you've got the latest. I made sure of that. Because it sit here a while, I didn't know. Okay. So it comes up here. Here's the status panel. It says connecting to the devices. Okay, the instrument's ready, and then the furnace. Now, what it did is it's always going to go back to the last technique that it was in before, and when we were in furnace before. So
It's trying to initialize.
yeah, that's the furnace, and this is the auto sampler. That's supposed to be pictures of the tray with samples in it. Not really good.
So if the furnace was off, it would just say.
Yes,
a fail.
it would hang out there for a little while, and then it would come up say cooked, which is okay because we're not going to run from it. And it remembers the group of windows I had up last. Okay, so we're going to go over here. Across the top, we have things that deal with the instrument, things with analysis, things about results, any utilities we're going to run, and techniques. Well, we're going to change techniques. This says furnace is round, have a check mark on it. We're going to go to flame. This technique will now be changed. Looks like it shuts down the software. It really does. It's a different version of the software. We've done that ever since we've had 32-bit software. There's separate programs running the flame. Okay, in the flame part, if you had a flame auto sampler program designed to do that, the gas box is a program that deals with it, and then one for the instrument. And you see it's connecting and making sure. Now we don't have a furnace. So,
Does it do the gas check like the old one did? Or no?
yes.
When, I believe when the old one would start up, they check and do like a gas.
No. Okay. Now, this I have set up for you. This is just what we refer to as a workspace. Okay? I could go here. First time you go into the software, it's just like that. So, coming across here, the Syngistics, okay, workspace, notifications, that's why. Yes, at the end of analysis, we could have it play a sound. I never even noticed that up there. If the QCs fail or whatever, you could have different, or when the flame goes out. So we don't say end of analysis, we want to play a little tune. We'll see what we got. Oh, wow, here we
That's
go.
a little too nice.
Yeah. And then you can do your own custom sound. That's probably
No, no.
you run through.
Yeah.
Or something. It's like that. I'm around people that have all these different ringtones. It's your mama calling. So, so the S up here does certain things. This is where your help is, how we arrange the windows, how we cascade them, close all the windows instead of bringing them all up before, and then Xing out of. Print an active window. You don't have a print. So
Well,
this.
no, well, once it's networked, we have a
Okay.
network printer.
Speaking of which, here is your network.
Okay, so
Yeah, it's got a separate one. It's
Mine
inside
is-
there.
okay, so it is
The
installed?
reason being, our ICPs controlled by Ethernet.
Ethernet. That's
So
what
we
I
have
was
to have
surprised
separate.
they, okay.
Yeah. Well, this one has Ethernet,
But it's just not programmed to use it?
but yeah,
Okay.
they never really used it. Yeah.
That's fine.
Yeah, but, so that they send a second one for it. because
But there's already
There's already one there,
network card.
yeah, so, but I actually like it this way, because, I come in, I set it up, and then you put it on there, because a lot of times administrators will set up users, and they don't give me the right
Yeah,
permissions.
permissions.
Yeah. So, and with our software, just to let you know, you have to be an administrator to load it. So, I didn't bring the computer down. You have two logins. You've got AA400 and you've got administrator. I put everything under AA400, which is we're administrators. No, I never put passwords on it. I'll let y'all do that if you want it. Yeah. Okay, so the workspace is right here. Workspace, and we're going to go open, or it shows what is there, manual flame. I love it too. Now, what is stored with this is the method that I use to run with it. So if I go to analysis and go to method, it's copper RL, curl. So if you run something daily, okay, you would just bring up that method, and if you like the windows where they're fine, you would just save it as nickel daily or lead daily or whatever. And then they don't have to go bring up this window and then go to method and open it. It's saved with the workspace. Mine's just two things that I check. I check copper sensitivity and precision on flame, and I check chrome sensitivity and precision on furnace. Chrome is up in the 357 range, and the reason you use chrome is if you got the furnace misaligned, the baseline will be negative. You will see it. It sees more light versus less. Less light's the positive number. So that's why we use chrome, to see how the optical system made it through. So when I fire with chrome, I want to see a nice flat baseline. I don't see any negatives. So that's, and it came in work just fine. it really did. I had, other than missing the card, there was no sneezes or burps. Yeah. So, what we have here, under instrument, we have devices. We don't have any devices attached to it. It would have been an auto sampler. Okay. Flame control, which is this right here. Okay. On to bleed the gases. There it is. But it's right there. Now when it always does this, when you bleed the gases, it will tell you that there's no pressure. Okay. But after it gets through bleeding, it comes right back. Oh, and the interlocks, it will tell you right here in real world words what it's missing. Why does it still think that there's no fuel pressure? Let's look and see. There's not any. Yeah.
Turn it on.
Yeah.
Were you safe?
Yeah. So it was okay. Now look, safety and all. If I raise the nebulizer up, this will tell me here just a little bit. No, nebulizer's missing. It's magnet,
Right, so it knows that,
and it may take it just a little while. So this is just how I like to see them. This is your manual analysis: analyze blank, analyze standard, analyze sample. If you have any QCs, this is where I want to save my data to. Sample information file generally comes from the auto sample. Okay? You go in and you look at it. We go to analysis. We go under analysis. I've got the method, sample information file, and this is called the analysis window. Okay? So we go to sample information file. All it does is allow you to say sample number 1 will be at whatever location, what I want to call it on the printout, and if I did any weights of volumes or dilutions of it. So that can be saved. And that's really good for people that run the same thing over and over in the industry, because position number 4 on the auto sample is always going to be this particular sample, and they always prepare it the same way. So they would call it up over here. Yeah. So they would say, okay, I want to use this sample information file, and I want you to save the results. So if I go here, I click Save Results. This is the install. If I want to change the name, I would go demo. And now anything that we run on this one will be saved under demo. And the information that it gets on this analysis page comes from the method. Now, we're going to make you a new method. So we're going to start right here. And I want to go, actually, we're going to go new method. And we're going to tell it, let's do the copper, recommended values. Now, it just gives you a heading. It would say copper, and then it would say what you used it for. Exactly. Typically, you want to take default wavelength instead. The difference is AA plus background or emission. Now, the background corrector on this one is a UV only, so it's generally from 190 to 300. You can use it like for your graphite furnace, because things that smoke can interfere with it. Well, what you want to do is if you're going up to a top of a cone or something above 300, just turn down the lamp so it's not driving the background corrector crazy. Now, while we're here, I'll show you, this is the background corrector lamp. Might as well show you what's there. This can be serviced by y'all. It's there's a catalog in the drawer there. They sent you a big catalog. You go in there. If you remind me, I'll load the PDF. Probably the only thing I didn't put on. I don't know if you ever remember the other one. It was, you had to take covers off. There's your line, right there. Little thumb screw. And then there's a notch that sits right here, so I would loosen this up, slide it out, and plug it from there. Plug in the new one, slide it back down, put the thumb screw in it. Comes pre-aligned. Very easy. Now we do have alignment screws here, see them right here?
Yeah.
That if you want to go to align lamps and verify that it's okay, you just adjust it for maximum intensity. I'll show you where that happens. And I would suggest if you're going to run multiple elements and then leave it on, y'all may not, but in industry, they'll make that waste treatment that use small AAs. They'll probably run something every hour or two. You do not make a background correction method the last method. If you do, remember to go and turn off the lamp. Because they don't, the deuterium doesn't last near as long as these. Yeah. So try not to leave it on when you're not running. So there's what your method is. Copper is typically no background correction. And the default is 3 second, 3 samples. That generally works real well. Now, remember I told you about if you wanted to set the current something different, so it matches it for like chrome or copper, instead of use the default, you say I want to use whatever this value is, and every time you type that method, you don't have to turn it back down. It remembers that. So this page just really says wavelength, if I'm going to use background correction or not, how long my readings are, and how many readings. And I can vary by sample. I'll press it here, I can say measure, I'm talking about auto sample. I can say if the concentration is less than a certain amount, use more, because there might be noise. If it's more than a certain amount, I'm already, this is really set for auto sample. I'm already above my limit, so just read it once, I got to. But typically, you leave it alone in calibration, which is your blank, and your standards, and your samples are already the same number of readings. But because people want choices, you got to go choices. Okay. Now, the sampler for this one only means the air and fuel ratio. So if we're in continuous graphics, you remember, it's continuously reading and you change something, it also updates these. So if you, especially with nitrous oxide, because it's temperature sensitive, right. And a few clicks may mean the difference from double sensitivity or half the sensitivity. Well, it's nice that when you're playing on here, it's updating here, and you get ready to close the method. So you want to save it, and you go, I didn't change the method. Well, it did. So it does it for you. Calibration. Typically, I leave it at nonlinear through 0. If not, you got to give it a linear curve. You see which choices are. Calculated intercept, linear through 0. Method of additions. Nobody ever runs that anymore. So typically, it's going to be linear through 0, linear calculated, or nonlinear through 0. And then whatever, how many decimal places. I don't like to see 4 significant digits. The world of AA used to have 3 and 3. I mean, 4 over here looks noisy to me. I generally leave it like that. And then you've got all sorts of choices for your calibration and your sample. Now, if you put them the same, it doesn't move the decimal place for you. If you make milligrams per liter and micrograms per liter, it will move it over. Say, some people want to see it in parts per billion, 1,000 parts per billion. I have customers that do that with the EPA method all the time. But you're calibrating parts per million. Why do you want to see it? I just do. So if you keep them the same, everything's good. Concentrations. Now, what are we going to call our blank? Typically blank. Okay. And then I can say just standard one, and then I have to give it the value. Now, it will always sign an auto sample location. We don't have one, so it don't mean anything to you. So give it 2.00, which is what I made up. Okay. And then it says initial calibration. It says you want to start by a new calibration every day. Typically, yes. Now I do have people that have 8 or 9 point calibration on the graphite furnace, and they'll call one up and then do a QC or a reslope. Okay. But so it will give you like an option of loading a pre-saved code that you're not able to do. Calibration checks. If you go over here, it says I want a coefficient greater than 995. Well, you got nonlinear. You're going to have greater than 995. So that really means something if you're going to be trying to stay in the linear range. And repeat calibration so many times if it fails and what to do. It's just making sure you got a good curve. Said not a lot of people do it. Precision check between samples, and you can tell it, okay, I want an RSD lower than this. Okay? If not, it's all really dealing with auto sample. So precision check, QCs. Got a lot of people who run QCs. Typically, people with flame don't run a second source QC. Okay? ICP do it all the time. Okay, but flame, their QC is going to be one of their standards. Okay? Can I come back? Did I get a good calibration? Can I come back and read my standards? Yeah. But this is really for the QCs. And once you set them up, then you give them limits, what they are, plus and minus 10. When to do it, after initial calibration. If you run an EPA, you have to do them every 10 times. If you do it after the calibration, 5%, every 10 samples, 10%, and everything. I generally teach my people to basically do the same thing with one of their standards, and then run at the end, and you know if it read okay. It's as good as your standards are. They really don't understand. And then what to do when it fails QCs. Okay? What you want your results